Hello and welcome to this short video on IGCSE Marine Science section 5.4, where we're going to look at the rocky shore. We have so far been looking at the open ocean, and now we're going to have a look at the different parts of shores where the ocean meets the land. As always, these videos here are made for my class, but anyone is welcome to use them. And any mistakes here, and there are many, are mine and mine alone. So when we look at life at the coasts, it becomes very important what zone they are in. And the zone here are defined by the tidal action. So if you are in a place where you're only reached by the very highest tides, or if you are a place where you're almost always underwater, will have a huge effect on who can live there, how they can live, what biotic and abiotic factors will affect them. So we divide these into the subtidal zone, the intertidal zone, and the subtidal zone, and we're going to go into a lot of detail about these later on in this video. On a rocky coast, the zonations are often quite easy to see. They're visible, unlike on a sandy coast. One of the things that are normal for a rocky coast is that the animals and plants living there attach themselves to the substrate, which means that they are some quite defined levels on where the different organisms live. The picture we see here is like a classical textbook picture, that it's not how it looks in real life, but we can often quite see like, okay, this is where we have the barnacles, this is where we have the blue mussels, this is where we have a seaweed, and so on. In general, when we're up in the splash zone and beyond, we are more in terrestrial zone, and the further down we go, the more life here becomes like pure marine life. But there are animals living here in the intertidal zone that kind of are able to live in both environments, which is why this becomes so interesting. On a rocky coast like this, there are different abiotic and biotic factors that will have a huge effect on the organisms who live here. And the abiotics are easy to understand, hopefully. The most important one being exposure to air. The higher up you are, the less you're covered by tide, which means you will be exposed to air. And if you're really high up, you might only be covered by water at high tide. So you need to be able to survive even when exposed to air. And for many organisms, that means they have to adapt in a way to avoid losing too much water. So you see many mussels, they're able to close their shells. So when they're out of the water, they close up so they don't dry out. You see seaweed that can be able to like collapse, and then when it gets below the water again, they can float up again and do photosynthesis. You see barnacles who can close up and like kind of stay, keep their water that way. So the ability to survive being exposed to air without drying out is something that is super important when you are in the intertidal community. Waves and tide will also have a huge effect on a rocky coast. Some of these rocky coasts can be hit quite hard by waves, so you need to find a way to survive that, either by attaching yourself really strongly, being able to move away and hide, like some crabs will do, or have a body shape that means that waves will not knock you off, like you see, for example, on some barnacles and some snails. Oxygen level will also vary, depending on whether you're covered by water or not. And so will temperature, both the air temperature and the water temperature. Here again, the book does not mention it, but there's a huge difference between a rocky coast in the tropics and a rocky coast, for example, in Norway. On a rocky coast in the tropics, the temperature, both air and water, will stay almost the same during the year, while if you are on a rocky coast in Norway, it can go from like 25 degrees in the summer to like being covered by ice in winter. So again, the organisms living here need to be able to adapt to that. Also, not mentioned in the book, but I should mention it, is that salinity can change, especially if you are in an area where there's a lot of rainfall, because when it then rains, water in rock pools and so on will become less salty. So again, organisms living there need to be able to adapt to that. So it's a quite harsh environment to live in that way. So you need really to be adapted to it. Biotic, of course, there is predation. So animals uh, often have a hard shell, like mussels, barnacles, snails, or they're able to hide. Food availability, there'll be competition for that, and there can also be competition for space, especially for the organisms who come in as a planktonic stage and then settle down like our blue mussels do. So our subtidal zone or our upper zone, the splash zone, is the zone that is most terrestrial, it's most land, which means that dehydration and exposure to salt spray is a big thing here. Extremes of temperature can change a lot, especially on the temperate or like subarctic areas. There are very few producers who live here because there's too little water for macroalgae to live there, and it's also an environment where terrestrial plants tend to suffer due to exposure to salt spray. So we'll often mainly see a few very hardy plants and some lichen, um, but they in general grow quite slowly, so the primary production here is not that high. Um, but you also will find to see animals who migrate here, who might not usually be here. But for example, on some coasts, you might see bears who walk down into this zone to look for scavenging and so on. So you have animals who otherwise, like mostly seen as terrestrial, will wander into this zone and further down on low tide to eat. The intertidal zone we divide into the upper, the middle, and the lower intertidal zone. The upper intertidal zone is very often not covered by water. It's only covered at between the high water spring tide and the high water neap tide mark. So these are areas who are quite often exposed to open air. So again, organisms who live here, they will tend to cope with dehydration. They have to be able not to dry out. Changing air temperature, the same as we see in the subtidal area. There are quite few producers, and you can get hit quite hard by waves when there are storms. So the animals who live here on the plants, they adapt to it. Here, you see some macroalgae who can live here, but not many. Um, but there are the Fucus spiralis, for example, where they have the air bladders who can lie down, and then as they get when high tide come again, they can rise up and they can do photosynthesis. The further we go down, the more producers we will start to see. And the more producers we'll start to see, this will also lead again to there's more food, more hiding places. As we'll also see some barnacles up here, some snails. As we get into the middle intertidal zone, we have more water coverage and it's less exposed to air. At the top, they are maybe covered by water at 20%, and at the bottom of the middle intertidal zone, they're covered by water at 80%. So there's a quite huge range we see here in the middle intertidal zone. You'll see a lot of tidal action here. The tide moves back and forth, it will affect it. There'll be some dehydration, especially in the upper part of it. But temperatures tend to be more stable, and we tend to see more consumers, herbivores and carnivores. And there's a quite high level of competition here, because this is where many organisms will like to stay. This kind of competition also will give rise to that some organisms might stay places they don't really want to. For example, the blue mussel would like to stay lower in the intertidal zone, but lower in the intertidal zone they tend to suffer from more predation from sea stars, so it can be an advantage for them to stay up a little higher, where they suffer more dehydration, but they also be less exposed to predation. Light intensity will be a little lower when submerged, but there are many more species of macroalgae who is adapted to living in this zone compared to our upper zone. The large amount of producers here also means more food. It means more place to hide. mussels, filter feeders, snails, also moving animals as crabs will live here. And we get into the lower zone, they are covered from 80% at the top to 99% at the bottom. So things living here are way more marine than we see up higher. And the conditions here tend to be more stable, both temperature, salinity, and everything, because the organisms are submerged most of the time. There's more water covering them. This can affect the light intensity, especially if you have an area with a big difference between high tide and low tide. Um, there's little exposure to air, so there's little chance of dehydration. There's a lot of producers here, so we'll see a lot of macroalgae here. There's a high level of competition. It's a nice place to be. There's less wave action, less issues with tide action, and but also less light intensity for some of the producers. So water here can be quite deep, um, but we'll tend to see many like herbivorous mollusks here. We will see limpets, top shells, starfish, crabs, and also fishes will start moving in here. The subtidal zone is the area just below. So here we are really in a pure marine environment. We will see many of the same organisms, like a lot of seaweed will be here. There's a high productivity, a lot of food chains because we are not that deep, so a lot of light. We are close to the coast, so we have runoff. They are placed to attach themselves for seaweed. So it's a very high productivity. Because of that, we have also many herbivores and we have many carnivores who will live on these herbivores here. We'll tend to see fish. We can also see animals as sea otters, seals, again, depending on where we are. But here we are moving into a pure marine environment.